We're going to do some more limits. We're actually going to do lots more limits over the next couple of weeks, but we're going to do some more graphical limits today. We'll do a couple different types of problems in class, but one of the types of problems is going to be where we're given information about a function and then we have to graph it. And so I want to do one example on this video just to set you up. This is something that students sometimes struggle with, so good idea to see before we get to class. So I have 4 different conditions that I'm working with here. I have the limit as x approaches 4 is 2. The value of the function at 4, f of 4 is -1. And then the right-hand limit of as x approaches 1 is -1. And then the left-hand limit as x approaches 1 is 3. So that's the information I have. I have to figure out how do I put this all together. And the key thing here is I'm graphing a function. And so we'll talk about how we have to put these pieces together to get that. There's one of these pieces of information that I think is easiest to start out with, and that's the fact that the value of the function at 4 is -1. That means the actual value of the function at 4 is -1, so I can put a closed circle there. So if I go 1, 2, 3, 4, -1. Okay, so I've got this point here. That's the f of 4 is -1, so I've taken care of that. So I have to have that point on my graph. It might not necessarily be connected to the rest of the graph, but I have to have that point there. Now I have to figure out how to deal with these limits. And so this is where things can get a little messier, but it's not usually too bad. So I think it's a little bit easier to start with the left and the right-hand limits. Sometimes it's easier, sometimes it's not, but let's start there. So this is our right-hand limit as x approaches 1 is -1. So I'm going to put an open circle there. We might close that circle in eventually, but I'll start with an open circle. Since this is a right-hand limit, that means as I get closer to 1 from the right-hand side, I have to be getting closer to this y value. So what I do is I stick a little tail here that's on the right-hand side. And because my function is going to have to meet up here. I don't know how it's going to meet up to everything else yet, but I'll figure that out eventually. And then this limit here tells me that as x approaches 1 from the left, I get 3, 1, 2, 3. So I'm going to put another open circle here. It's a sad looking circle. And this is from the left. So to the left of 1, I'm coming in here. So I'm going to put that little line telling me that as I get closer to 1 from the left, the y values get closer to 3. Now, the limit as x approaches 4 is 2. This means that the limit exists, which means from both the left and the right, I have to be getting closer to 2. So at 4, 1, 2, I'm going to put an open circle there, and I need lines from both the left and the right, okay? Because that limit was not a left or a right-hand limit, I need it coming from both sides. So now I have to figure out how to connect all these dots, and that's the hard part. I also noticed that I need a function. Remember from pre-calculus that functions must pass the vertical line test. And this is oftentimes where students make a mistake, is making something that's not actually a function. So to pass the vertical line test, that means, remember, as I put a vertical line across my graph, I don't want the graph to intersect at more than one place. So I'll draw something that is actually a function, and then I'll show you something that's not. So we need to connect all these little lines. So I noticed that these 2 pieces could connect to each other. And then these other pieces don't even have to connect. They can just keep going. And that's because they're kind of the furthest parts on the left and the right. Notice that this open circle down here doesn't connect to anything. That's okay. The limit was equal to 2, but the value of the function was not 2. So there's an open circle with a closed hole. That's fine. So this is what we want as our final answer. It doesn't really matter how we connect these 2 pieces here. The graph might do something like this. We don't know. That's okay. So however you connect those 2 pieces is fine. Similarly, at the ends, it could go down. Oops. Could do something like this. We don't know. So if you make it go up, you make it go down, that's fine. As long as the limit information is satisfied. And similarly over here, it could do something like this. We don't know. So this is also a valid answer. The thing that you don't want to do, and this is something that students oftentimes do, let's go ahead and put those original lines that we have, is we don't want to make this something that's not a function. So you might be tempted to say, okay, well, sure, I'll connect these 2 guys, but then like these 2 people, maybe I want to connect those 2 dots. Don't do that, because what you just drew is not a function. If I look at a vertical line here, like this vertical line, that crosses the graph twice. So it fails the vertical line test, which means that what you drew is not a function. I asked you to draw a function, so this is not going to work. So that's why we can't like connect these endpoints to anything else, because you would get something that's not a function. So you're going to need to have a hand or an eraser handy for these types of problems, because sometimes you draw something that doesn't work and you need to try again. So we'll do several examples in class of graphing functions like this, and hopefully it will be more comfortable then.